All right, guys, as promised, I'm going to show you how to make your own manual boost controllers. So if you're in a pinch, you can make one of these real quick. You know, if you're heading to a dyno day or you're wanting to kind of experiment, test things out. This is a ball and spring type. I was inspired by Sane. He actually has a video on YouTube of how to make these as well. About 5 years, I think it's about 5 or 6 years old. But I made my own little improvements to it and a few other little things. I think he actually videoed it with one hand and doesn't really go crazy in depth on how to build it and some of the little nuances to it to getting the ball to seat a little bit better. But yeah, so let's run up to the store and grab the parts we need. All right, so what you're gonna need is this fitting right here. It's like less than $4, like $3.50, 1/4 inch by 1/4 inch MIP. So we're gonna grab one of those little dudes right there. Then you need a 1/4 inch by 1/4 inch FIP. It's like $3.69. And then you're gonna need this over here. This is a 1/4 inch by 1/4 inch MIP elbow. Grab that. And you wanna come and grab this 1/4 inch by 3 1/4 inch by 0.25 inch spring. So grab a pack of these. To the air tools aisle, you'll be able to find this fitting right here. So, and then to the hardware aisle in the specialty section, ball bearings. Usually in this little drawer right here, it'll just say ball bearing. It'll have a stainless steel ball bearing right here. It's 85 cents for this guy. Make sure that you get the right one because sometimes they're all mixed around. But I had to come to Home Depot because Lowe's, at least in San Antonio, they don't carry these little ball bearings. So I had to come to Home Depot for these. All right, so now you got your parts and you're gonna start putting together your manual boost controller. As I mentioned before, I had to go to Home Depot and Lowe's. The reason being, I'm more of a Home Depot fan than I am of Lowe's, but when it comes down to it, Lowe's just has the better fittings. The inside, you don't have to worry about looking for them. They're all gonna be perfect and machined properly. Same goes for these. Their seats are usually a lot cleaner than the Home Depot ones. I don't know if it has to do with just the branding or the vendor or whatever they use, but this vendor for some reason is just a lot better than what Home Depot carries. So for this stuff, oh, and the spring. I can only find this spring setup at Lowe's. And the ball, unfortunately, Lowe's doesn't carry the ball. You have to get this from Home Depot or wherever you can find a 1/4 inch steel ball. If you can find stainless steel, better. The nickel content's gonna have better corrosion resistance, but you should be just fine with plain steel ball like this. But yeah, so these are all the parts you're gonna need. I'm gonna go ahead and take them out of the package, show you what your setup looks like beforehand, and go through the various little steps that you're gonna do before assembling it. All right, so here's a blown up version of what the manual boost controller is gonna look like before assembly. There's a few things that we're gonna be doing. We're gonna be chopping this elbow off, clearancing this bottom thread portion, and we're gonna be tapping this fitting to run this M8 by 1.25 bolt. Then we're gonna be stretching this spring and then relaxing it to where we can make our spring and then cutting it to fit the height that we need. We're gonna be drilling a hole in this body. It's a relief hole, 1/32 inch. That's very important. There are a lot of manual boost controllers out there that you can buy online that don't get this part right and you end up having some issues. I'll explain that later. And then we're gonna be indexing this bottom fitting right here to better seat this ball. So there's a few things that we're doing in here that are really important steps that take this from being just a mediocre or even just being a piece of junk and turning it into a fantastic, consistent device for less than 20 bucks. I mean, once this thing is done properly, it's gonna be better than anything you're gonna buy on eBay, really, to be completely honest. And I don't really like to make a whole lot of recommendations on this channel, but if you are hell-bent on going out and buying your own manual boost controller, just get the best. It's a DAWS device. They're about 65 bucks for a hybrid one, and I personally don't know of a better manual boost controller than a DAWS device. They have everything spec'd out right. All the parts are just, they're correct. And it's kind of elegant. It's an elegant little solution. It's very minimalist. I personally really recommend that. I ran a Grimm Speed Boost controller. It ran just fine, but it's also $100. DAWS device for the win. I don't know them. They don't know me. I'm not sponsored by them in any way, but of course, I'm gonna recommend this setup because it's cheap, and if you get good at it, you can sell it to your friends, and guess what? Your boost controller was free. So anyways, so let's get going on making these modifications. All right, so this is the setup I'm gonna be using to drill the relief hole. I bought this little Dremel kit. It's 1/32, which roughly it's about 0.8 millimeter. And then 3/64 is about 1.1 millimeter, which is okay, but you don't really want to go over 1 millimeter. But you know, it'd be okay for this application if you had to. And you just buy this little collet set and plug it into your Dremel, and you're good to go. You can drill this relief hole, so let's get that knocked out. All right, so I'm gonna grab my punch, make a little indent right here. Let's see, about right there. And now I'm gonna make a nice clean hole. I'm gonna use about 25,000 RPMs to get this going. And that's it, just like that. We're gonna clean this thing out. And there you have it. Nice little relief hole. So I kind of glossed over this relief hole and its importance, but it is important. Let me explain it to you real quick. I'm not gonna drone on about it, but it is important. I wanna show you why. So if you don't know how a manual boost controller works, there are plenty of videos out there that explain it, but for this sake, I'm gonna show you. You have boost signal coming into your manual boost controller down here, and you have your ball already set to a predetermined load. So let's say it's 15 pounds. Right, so at 15 pounds, the ball is going to move up. Your air is going to come in from the boost signal. The boost signal is going to travel through this tube, and it's going to head over to your wastegate. And your wastegate's going to open, let the exhaust gases pass, and it's going to slow down the turbine wheel, thus decreasing boost, right? So you're still going to have a little bit of inertia left over, so that's where you get boost spike and all that, but that's for another time. Anyway, what happens though is when you let off the throttle and there's no longer boost signal going to this manual boost controller, the ball shuts, but the air from when the spring is trying to close this wastegate shut, now there's a buffer of air inside of here that's trapped and it can't get back out. So the importance of that little relief hole is that when this wastegate is trying to shut back closed, that there's zero resistance in the line keeping it from doing so. Is it a big deal? You know, there's conjecture out there, but I like to do it anyways because it doesn't affect anything adversely. What'll end up happening is if you have too big of a hole over here in the relief, you'll notice that when your boost signal's coming in, you might have a taper where it kind of tapers off in boost and then goes back up and spikes. So that's why it's important to keep that hole small. But if the hole's small enough, you won't notice anything at all. You'll hit your target boost. And that's another benefit to the ball and spring type versus a bleed type. I'll talk about that more towards the end of the video, just for the sake of getting this thing built. But there's an important difference, especially for metered air cars, and why you want to use a ball and spring. Yes, it's going to make the car feel faster than a bleed type, and also there's a reason for it. So I'll explain that later. Let's get back to building this thing. All right, so here are the tools I'm going to be using for this next step. We're going to be chopping the top of this elbow off and clearancing this to match this piece right here. So to basically take a marker and get it to where this piece will bottom out into here. So we'll do that. And I'm just gonna be using either this little hacksaw or a razor blade. You can heat this up and push it through it if you want. If you want to embrace your inner masochist, you can just do it with the razor blade. It's gonna take you a while, but it's doable. And then M8 by 1.25 tap. And then a 1/4 inch drill bit is what I'm going to be using to drill the hole so this thing can sit in here. And as you can see, it has like a small hole in it already. So there's your pilot, yay. So let's get going on this real quick. Well, I didn't get video of chopping the little elbow off. I guess my phone stopped recording for some reason. Anyway, this is where you want to mark it about, just to make sure that when you actually go in here to cut this piece, that this piece will bottom out inside of here on that little face, or just before it. You don't want it to be too long, or else it'll kind of stick up, or you don't want it to be too short's okay, but too long you don't want that. All right, now we're gonna drill the hole. Just make sure that you don't have the vise clamped too tight because you don't want to deform the plastic too much. so I have the M8 by 1.25 thread tap. Try to start it by hand here. And yeah, I know I drilled the hole with a 1/4 inch bit, but I don't have a metric set to drill with. So if you're screaming at me through the computer, I'm sorry, but this works. It's just plastic, so no big deal. And that's the beauty about using plastic, is that when the bolt goes in here, it's gonna create a nice sealing surface and you don't have to worry about running any kind of sealant, and it's adjustable, and you don't have to use a jam nut with the plastic. So when the bolt actually threads in here, it'll have enough resistance on it to A, keep the air from passing by the bolt, and B, have enough resistance to keep the bolt from unscrewing even with vibration. So this acts like a buffer for vibration as well. So when you actually torque this into the seat, it's good to go. You don't need that little jam nut. It's pretty neat. All right, so let's check the fitment of the bolt in the top of this cap. Now keep your tap handy just in case when you put this back in, it squeezes it a little bit, but let's try it out. It should feel kind of firm the whole entire time. So like it takes some force to actually thread this in there, and that's a good thing. So it shouldn't be extremely easy to turn this at all. It should require some pressure for sure. So this feels really good. And I think it's gonna change a little bit when I get it installed. It's probably gonna be even harder to turn, but let's try it out. Now this part's a little tricky right here. Sometimes this goes in really easy and sometimes it doesn't. So you have your relief hole. This is gonna be the top. Sometimes you get lucky and this will just pop right on, and other times it is a disaster. All right, wish me luck on this adventure. Sometimes these go in really, really well. Sometimes they don't. Money. All right. Now you don't want to smoke it in there too hard, but yeah. So now it's in there. Let's check this thing out real quick. So yeah, we have a nice flat, even surface all the way around. And don't worry if it's a little off, it'll kind of correct itself once it gets inside. But you will have to probably run the tap one more time in there just to make sure it's all good to go. But I feel like it's gonna be pretty tough. No, it feels good. Actually went in pretty decent. Okay, so I have good pressure on the bolt. It's getting really hard to turn by hand, and that's important. That's what we want. Yeah, okay, cool. So that's a good setup. Almost to where you need a tool to take this thing in and out. So there you go. And if you did everything right, it'll be nice and straight like that. Alrighty, moving on to the next step. All right, so now we're gonna go ahead and start stretching and relaxing the spring. So what you're gonna do, find out about where you're at. This looks to be 3 3/8. So we're gonna stretch this, and there's no exact science to this. I mean, honestly, just, I'm gonna give you measurements here to go by, but it could be however. So I'll just stretch it out. You know, I don't know. Let's start with 2 feet first, see how it relaxes. Yeah, we want a little bit more than that. So let's try stretching out to like maybe outer space, because that's where that thing went. Hold on one second. Okay, give me a second to reset here. Sorry about that. Okay. All right. Let's try 30. That looks good. Okay, so this thing, when it's kind of relaxed right now, it's sitting at about just under 15 inches. Looks like 14 3/4. All right, so we're not done yet though. We need to truly relax this spring. So let me go grab a screwdriver or a little shaft of some sort to put in this so we can compress it down and actually relax this spring. I have a little piece of TIG welding filler rod that I'm gonna put the spring on. You can use like a shank of a small screwdriver, whatever works for you. And you're just gonna take this thing, get it on there, and then just compress it down all the way. Do it a couple times. All right, now let's do it one more. Yeah, all right. So it should come out to probably about, I don't know, 11 and a half, 12-ish. Let's see if I'm right. Heyo. Yeah, we're at about 11 3/4. So that's relaxed. So now what we're gonna do is we're gonna measure the spring and cut it so it fits inside here right. All right, so the way I go about measuring how far I need the spring or how large I need the spring to be is kind of rudimentary, but it works good. What I'll do is I'll first start by inserting the ball into here, and then I'll screw it on, and we're just doing a test fit. It doesn't actually have to be perfect. I'll take this setup with a 9/16 and a crescent, and I'll just tighten this thing on a little bit until it gives me a good amount of resistance. Let's see. I don't want to smoke it on there, but just a good amount of resistance. There you go. That's good. Okay, doesn't need to be crazy. Just pop that guy off. All right, and then do is kind of make sure the ball's seated down in there. I'm gonna take this rod, fish it down in there. So I know that it's sitting on top of that ball right now. And I'll take this. Now you could do this all kinds of ways. You could measure everything, you could take it apart, you can do all that stuff. I'm just saying that it doesn't have to be that accurate because you're gonna be making all of your adjustments with this bolt right here. So it doesn't have to be crazy accurate, but if you're one of those types of people for this particular situation, you can do that if you want. And then what I do is I come over here and I see, okay, wait a second. I don't want the spring up in here. I just want it down here. So I know that that's my height right there. So I want to subtract this distance right there. So I just come down to here and I make my new mark right there. And that's it. That's how big you want your spring to be. You can make it a little bit larger. That's okay, because the bolt will kind of compress it down just a little bit. It's all right. So that's where we want our spring to be. You'll take your spring. First off, cut off this end real quick just to make it nice. Let's cut off this end real fast. Okay, so we just got that nice little end. Come over here, line it up. Okay, so we know it's about right here. Let's go just a little bit higher. There we go. How about right here? That'll work. Try not to deform the spring too much. There you go. You have your spring. Voila. All right, so I'm gonna clearance this end a little bit. I just use a number 2 Phillips, and I go in here and very lightly, I get it lined up, and I just rotate it just a little. Nothing crazy. You don't want to put a lot of force on it. Maybe a pound or two, not even 2 pounds, just a pound of force over the top of it. And that's all you need to do. And then take it out, blow it out. That gives you a nice little beveled edge in there. But then I take it a little bit further just because it gives better results. I take the steel ball bearing, put it inside of here, and then I take a punch that's just about the size of the opening, and I place it over the top. And with a ball peen hammer or another light hammer, I'll give it a light tap. Nothing hard. You don't want to hit this thing really, really hard. Just a light tap. Just enough so the steel ball bearing will deform the brass end. So let's do that. And that's it. It's literally all you have to do. Now, when you put this in here, it has already done some of the work for you. So a lot of the manual boost controllers, they say, oh, they break in over time because the steel ball wears its way into the brass fitting. Well, they're not wrong. That is true. That does happen. But this is kind of making that process a little bit faster. So you've kind of deformed the end of that to fit that ball just a little bit better. And over time, it will get better. It will start seating a lot better. But for right now, it gets you where you need to go. So let me see how this performs real quick. Yeah, that's really good. Okay, so here, I'll get closer to the camera. Can't hear any air escaping. Yep, so that's perfect. Controller, so this is it. This is the part you've been waiting for. I do use some fast tape on this. I know some people are gonna be screaming, oh my gosh, you don't need that for brass fitting with MIP to MPT. You'll be just fine without it. Well, that may be the case, but I like thread sealing my stuff. So anyways, what you'll do is if you do wanna use some Teflon tape or PTFE or whatever, if you wanna use some of this type of tape, always make sure that you go in a clockwise direction of whatever the threading is. So in this case, you'll go clockwise, and then on this one, you'll go clockwise. So you'll set it up, go clockwise. That way, when you actually thread it in, it doesn't undo the tape and bunch it up and make a mess. And for this stuff, normally, for like normal pipe threads, you'll probably use like 3 wraps, 3 solid wraps. But for this stuff, I like to just use 1.5. That seems to work really good. So let me get that done. And once that's finished, we'll go ahead and assemble this thing and be done. Okay, so the thread tape's installed. One of the things that I like to do right before assembling is I like to mark on the bolt about where it's gonna come in contact with the spring when it's in the body. So as you can tell, if you put it right here, it's about the thickness of this, because as you remember, we cut the spring to be about right here. So this will let you know roughly when the tip of this bolt is touching the top of that spring, and you can make your adjustments from there. It's just a little thing I like to do with a silver Sharpie before putting it all together. All right, so basically you'll take this spring, drop it in here. You'll take this ball, drop it in here, real simple. You'll put these 2 pieces together. I'm probably gonna go ahead and put this in the vise just to tighten everything down. But there you go. Right? Make sure that your relief's on the top. Okay, and then you'll go ahead and place this in here, like so. Okay, and then now we can place our bolt in the top. Sorry if you notice that I shake a lot in my videos. It's a blood sugar thing, so if you ever see me shaking or fumbling with things, that's why. So, you know, it's not that I'm just clumsy or anything like that. It's just sometimes I shake. But anyway, all right, so there you have it. That's the assembled piece. Now we're just gonna go ahead and take it over to the vise, lock it in, and that's it. All right, so she's locked up in the vise. I went ahead and tightened this down just a little bit. This is a 5/8 that I'm using to tighten down this side. You don't need a lot of torque on this because brass has a tendency to split when it's over torqued. Basically, the best way I could say to torque it down to without, if say you don't have a torque wrench or anything like that, is you'll get it nice and tight. And then once it's to a point where you're actually having to exert some physical, like actual force at about 6 inches away on your wrench, you go about half a turn and that's it. Don't do it anymore. You just want it nice and snug. I mean, you should have a feel for it. I mean, I don't really know how to explain it without using like torque numbers, but basically you're just wanting to make it nice and snug. Don't overdo it because you will crack brass. And then flip this over. Just lightly put this in here. Let's see. Don't smash this piece down. Okay, cool. And then you'll use a 9/16 over here. And let's see, is this one already pretty snug? Yeah, okay, so yeah, I already tightened this one down. Again, nice and snug, don't over tighten, you will break it. All right, now that that's done, you'll come over here and I want you to hear something. So you see where we marked, remember when we marked this on the top of the bolt, or on the bolt? Hear that? That's the ball bearing, bouncing up and down in the seat. Okay, now let's see how close we got it. I'm gonna go ahead and screw this Allen bolt down. Actually use this to the exact mark that we put before. Let's see. Yeah, it's called there. Nothing. Literally nothing. So that's how you know you made the right marks, the right measurements. The tip of that bolt is now touching that spring, which is keeping the ball in the seat. Now let me do a little test. Good to go. No air is getting past it. And voila, you have yourself a less than $20 hardware store part manual boost controller. How cool is that, huh? So if you're in a pinch, now you're sorted. I was gonna say a little bit more about manual boost controllers, you know, talk about the bleed type, ball and spring type, all that jazz. Honestly, there's a lot of videos out there, there's a lot of information already about it. I will just touch on it a little bit. If you have a metered air car, so if you're running, you know, like a MAF or anything like that, you'll probably want to stick with a ball and spring type. That'd be your best bet. And also what's cool about ball and spring is it allows you to build up to target pressure in a much more linear fashion. Beautiful. And you know, yeah, you're gonna have a little bit of boost spike and stuff like that. The only real way to get rid of that, as I may have mentioned earlier, is an electronic boost controller. Just the way it pulses the air between atmosphere and the pressure section. It gives you a nice, real nice linear boost, and then it keeps it from spiking. So obviously if you have the money for a solid electronic boost controller or integrated type, then go that route, of course. But if you're looking for a manual boost controller route, then here you go. This is the way to go. I guarantee you this little part is better than anything you're going to buy on eBay or any of those cheapo stuff. Aside from like a DAWs device, this is the best thing that you can possibly put on your car. It's not the prettiest, but it works. It's far better than those other things that don't even have the seats properly done or relief holes are the right size or anything like that. I don't know, I might be biased, but it has worked for me for many years. It was worked for a lot of other people for many years. It's just a tried and true design. It's not my design. You know, it's just something that I was inspired by a long time ago. Justin and there's a few of my other friends just made a few of my own little improvements on it. But anyway, yeah, this is the way to go if you're in a pinch, or you know, you don't have a lot of money on you or anything like that, and you just want to make something that's reliable and easy. Go this route. All right, friends, so if you want to win this thing, just comment down below. Obviously, I don't have any use for 2 of these, so comment down below what you'd use it for, what you're working on, your plans, and then by the time I have another video, I will announce the winner from the comments section, and I will get your information and I'll send this bad boy out to you. So yeah, as always, thank you for watching. Cheers.